Walking 6/7 of his usual speed, a man is 12 minutes too late. What is the usual time taken by him to cover that distance? Well, distance is equals to speed into time, right? Let the distance be d and the regular speed be s and the regular time is t. Now what he says is 6/7 of the usual speed. If he walks in this speed, the man is 12 minutes late. Now the distance is same, so we have d is equals to, the speed is 6/7 of the usual speed, so 6 by 7 s times the time. What is the time? The man is 12 minutes late, which means that he takes 12 more minutes than the usual time, so t plus 12. Now you can just equate these two terms because the distance is same, so you have st is equals to 6 by 7 s t plus 12. So s and s get cancelled out. What you have is 7t is equals to 6t plus 12 times 6 is 72. So 70 minus 60 is t, that is the regular time, which is 72 minutes. Now 72 minutes can be split up into 60 minutes plus 12 minutes. And 60 minutes is 1 hour. So 1 hour and 12 minutes is the regular time taken by him to cover the distance. So option B is the correct answer. A train, when moves at an average speed of 40 km per hour, reaches its destination on time. When its average speed becomes 35 km per hour, then it reaches its destination 15 minutes late. Find the length of the journey. Now let the length of the journey be x kilometers. And we have been given that when the average speed becomes 35 km per hour, the train reaches the destination 15 minutes late. Let us convert this 15 minutes to hours. Well, 15 minutes is 1 by 4 hours. Now what we can do is we can take the difference of the time when the train travels at 40 km per hour and when the train travels at 35 km per hour, and that will be equals to 1 by 4 hours. So t1 minus t2 is equals to 1 by 4. Now what is t1? t1 is the time taken when the train moves at the speed of 40 km per hour. Time is distance upon speed. So distance is x upon speed is 40 minus the time t2 is the time taken when the average speed is 35 km per hour. So again distance is x upon speed is 35 is equals to 1 by 4, the difference between these two times. Now you can calculate the value of x. When solving this equation, you'll get the value of x as minus 70. So you can always ignore the negative sign because distance cannot be negative. So the correct answer is option C. If you're wondering why this came out to be negative, we took the difference opposite. We should have taken this difference as x by 35 minus x by 40, right? So that's why it came out negative. Nevertheless, we got the correct answer, option C. A train can travel 50% faster than a car. Both start from point A at the same time and reach point B 75 kilometers away from A at the same time. On the way, however, the train lost about 12.5 minutes while stopping at the stations. What is the speed of the car? Well, we have been given the distance between point A and point B. So distance is 75 kilometers. Now let us consider that the speed of car is x kilometers per hour. Now it has been given that the train can travel 50% faster than the car. So the speed of train is equals to 150% of the speed of car. So 150 by 100 of x, and that is equal to 3 by 2 x kilometers per hour. That's the speed of the train. Now it has been given that both the train and the car reach the destination at the same time, which means that the time taken by the car is equals to the time taken by the train. But the time taken by the train is equals to the exact time taken by the train plus the 12.5 minutes that it lost while stopping at the stations. So the time taken by the car is TC is equal to time taken by the train plus 12.5 minutes. So 12.5 minutes will have to be converted to hours. So 12.5 minutes will be 12.5 divided by 60 hours. Okay, so what is the formula for time? It is distance upon speed. The distance is 75 kilometers. So 75 upon the speed of the car is x kilometers per hour. It is equal to, again the distance is 75 upon the speed of the train is 3 by 2x. So 3 by 2x plus 12.5 by 60 can be written as 125 by 10 into 60. When you'll solve this equation, you'll get the value of x as 120 kilometers per hour, and x is the speed of the car. So the speed of the car is option D, 120 kilometers per hour. In covering a distance of 30 kilometers, Abhay takes 2 hours more than Samir. If Abhay doubles his speed, then he would take 1 hour less than Samir. What is Abhay's speed? So first of all, let us consider that speed of Abhay is x kilometers per hour. And let us also assume that the time taken by Samir is t hours. Now we have two situations here. In the first situation, Abhay takes 2 hours more than Samir when his speed is x. So we know the formula for speed. Speed is equal to distance upon time. When the speed is x, the distance is 30. The time Abhay takes 2 hours more than Samir. So 2 plus t. Now in another situation, we have that Abhay doubles his speed and he takes 1 hour less than Samir. So Abhay doubles his speed, so speed is 2x. It is equal to distance remains the same. So 30 by time. This time he takes 1 hour less than Samir. So Samir's time is t. So t minus 1. Now let us modify these two equations. We have 2 plus t is equals to 30 by x, and we have here t minus 1 is equals to 30 by 2x. Again here t is equals to 30 by x minus 2, and here t is equals to 30 by 2x plus 1. Now we want to calculate the value of x, so we can, we have the left hand sides as equal, so we can equate these two terms. So I can write 30 by x minus 2 is equals to 30 by 2x plus 1. So I have 30 by x minus 30 by 2x is equals to 2 plus 1 is 3. On solving this, you'll get the value of x as 5. So x is speed of Abhay, and that's what is asked. So the speed of Abhay is 5 kilometers per hour.